Here's a really strange example of infinity. This is just a pool tube. I bought it at the pool store. If you know that it's also a musical instrument, if you swing it around, you get a note. Now, you might think that if you swing it faster, you get a higher note. You might think that there's an infinite continuum of notes. A little bit faster, you get a little bit higher note. And that's partially right. You do get an infinite string of notes, at least in theory, but it's not a continuum. Listen. It jumps up. It's actually discrete steps. It's a countably infinite sequence of notes. You see, both speed and length are important here. You only get notes with wavelengths that fit nicely inside of this tube. The wavelength of those? Well, if you think of this as 1 unit long, the wavelengths are 1, 1/2, 1/3, 1/4, 1/5, 1/6. In practice, you only get a few, but those are the numbers from the harmonic series. We saw those when we were stacking books. And that's where the name comes from. It comes from the connection with music. It's important in musical applications. Anything you can play on a bugle, which is just a tube, you can play on this. The same mathematics tells you that electrons can't have just energy and energy level. Those levels are discrete. This idea of discrete versus continuous, those are very different. Different sizes of infinity, as you'll see.